we are going to do a bonus average atomic mass question. What does this mean? This means that I may not go over this in class, but if you're watching this now, you may end up being well prepared for a test question. Okay? So this is just a different variety of an average atomic mass calculation. Okay? Let's say that we have the two isotopes of carbon, which are carbon-12 and carbon-13. Carbon-12 has a mass of 12.000 atomic mass units. Remember that carbon-12 really is the reference point for measuring the mass of an atom, and the mass of an atom has been assigned 12 AMUs for carbon-12. So 1 AMU is 1/12 a carbon atom's mass. Carbon-13's mass is 13.003 AMUs. Okay? And if you look at carbon on the periodic table, it's atomic number 6. And what is its mass? It's 12.011 AMUs. That's its average atomic mass. So here is our average atomic mass. Well, what the heck, you say? Well, we already know the average atomic mass, so who cares? What we don't know is the percent abundance. So here's the different twist. Rather than you calculating the average atomic mass, you're going to calculate the percent abundance. So we have to do a little algebra and using some variables involving x. Okay? So what I'm going to do is I'm going to let x equal the abundance, the percent abundance, put a percent there, percent abundance of, I'll just say carbon-13, and it really doesn't matter which one I choose. It'll work out the same way for either one. So if x is the percent abundance of carbon-13, that means that 1 minus x would equal the percent abundance of carbon-12. Now, why is this, you say? Well, just as a little aside, remember that our percent abundances, when we do our calculations, are expressed as decimals. So, for instance, 75% equals 0.75. And if I had a 75% abundance for one isotope, that would mean its pair would have as percent abundance of 25% or 0.25. We know that 75 and 25 is 100%, but as decimals, they add up to 1.00. So for our values here, x and 1 minus x, they'd have to add up to 1.00. So 1, that's where we get the 1 minus x versus the x, okay? And if you don't quite get that, you can rewind this tutorial and check back over here. There's nothing wrong with listening to this a couple of times until you completely understand it. Now what we're going to do is set up an algebraic equation, okay? So since I'm letting x equal the abundance of carbon-13, what I'm going to do is I'm going to take x times the mass of carbon-13, which is 13.003. I'm going to add it to 1 minus x, which is the percent abundance of carbon-12, times the mass of carbon-12, which is 12.000. Okay, and I am going to set it to the average atomic mass, which we already know to be 12.011. So now I have my equation set up, but what I'm going to do is rearrange it a little bit so it looks a little easier to understand. So something more familiar in its form in what you see in an algebra class. So this becomes 13.003x, all right, from here to here, plus here I'm going to multiply, and I'm using the distributive property. So multiplying 12 times 1 is 12.000 minus 12 times x. 12.000x equals 12.011. Now I can do some math. And I see here I have 13.003x minus 12.000x. Well, let me rearrange that first, just so it's easier to see. Okay, all I'm doing is rearranging my numbers, which I certainly can do. All right, now it's easier to see. So I have this quantity here, and I could subtract this. So 13.003x minus 12.000x becomes 1.003x. All right, plus 12 equals 12.011. Now I can subtract 12 from both sides, so I end up with 1.003x equals 0.011. Okay, now all I need to do is solve for x. So x is going to equal 0.011 divided by 1.003. And when I do that division, I end up with 0.011. Now, if you don't believe me, because you're probably looking at this and saying, wait a sec, 0.011 is my numerator. How can I end up with the same thing? Well, let's take a look at the calculator. Okay, so 0.011 divided by 1.003 equals. Okay, I got 0.0109. Okay, but what I was doing was rounding. Now I had to round to 3 sig figs, since this number has my lowest number of sig figs. So I'm rounding to 3 sig figs. So I end up with 0.011. So that's just the math check, in case you were doubting me. All right, which is perfectly okay. So that's what we end up with. This is the decimal form of our percentage. And if we want to go to a regular percent, so we're going from the decimal to a percentage, we're going to take that decimal place and we're going to move it 2 places to the right, bing, bing, like that. That is the same as multiplying by 100. All right, so I end up with 1.1% as my percent abundance for x. So x equals 1.1%. So what is 1 minus x going to equal? Or I should say, now we're not doing really 1 minus x, but we're doing 100 minus 1.1%. Since our percentages have to equal 100%, x, which was the abundance of carbon-13, here's our abundance of carbon-13 is 1.1%. So what's our abundance of carbon-12 going to be? If this is 1.1%, this guy is going to be, and if you don't believe me, we can pull out the calculator. So 100 minus 1.1, hopefully we can really do this in our heads, is 98.9%. So the percent abundance of carbon-12 is 98.9%. So look at that. We went from the masses of each isotope and found the percent abundance of each isotope. We took that mathematics, or the equation that you guys have been normally doing, and we have reversed it. So if you study this, you may do very well on a short answer test question.